Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to format output and use strings as well as do some input. So let's start off by opening up Visual Studio. We'll create a new project. We'll make a C++ empty project, and we'll call it input output demo. I'm going to store it on the desktop and click OK. Once our project opens up, I'm going to add a new item. We'll call it iodemo.cpp. And when our IO demo file opens up, the first thing we want to do is make sure that we set our console properties for the project. I'll go to right-click on Project, Configuration Properties, Linker, System, and I'm going to set my subsystem to console, and so that my console will stay open when I run. Next, I'm going to start writing my code, and since this is a C++ program, I'm going to include the IO stream. And I'm going to use the standard namespace. And start off by defining my main method. I put some comments in for my header, and now I can begin writing some code. So we're going to define pi as a constant. By using the constant keyword, this will ensure that pi is only defined once. However, we won't be able to change pi later on. For my other variables, I'm going to define them as normal variables, as doubles. and we're going to display these values. When you use /n, that slash will provides an escape sequence with the n signifying a new line. And later on we're going to use some input-output flags, but for now we're just going to display the values so that we can see what they look like without any flags set. Running this, I'll run it with debug start without debugging. Notice that there's a shortcut key, Control F5, which I could use as well. And since I didn't hit build initially, it'll come up and ask me if it'll tell me that the program is out of date, which means it hasn't been built yet. And so I'm going to say yes so that it builds. Once it completes building, it will bring up the console window, and we can see that it does in fact print what we expected. Next, I'm going to see if I can modify pi. And we notice that immediately IntelliSense gives us an error. Expression must be a modifiable value, and the reason why it gives us that is because we declared it as a constant. If I deleted constant, we see that the error goes away and we can modify pi. But if with the constant keyword, we can't change pi. We also notice down in our error list that we get that error. So the next thing I'm going to do is just comment this out because I know I can't do it, and I want pi to remain 3.14, 159, 26, etc. So the next thing I'm going to do is use the precision method for the cout. So if I set precision equal to 5, we'll see what this does when we display our output. So we're also going, in addition to setting precision equal to 5, we're going to set an iOS flag. And the way these functions work are cout is actually a class, and if I type cout and put a period, I can see there are a number of methods that are actually available for me to use associated with cout. That dot operator is a class operator. It's called a class operator or a dot operator, and since if we put it next to anything which is a class, what it will do is it'll give us a number of methods. We're going to talk more about classes later on, but for now, just realize that if I type cout and I put a dot, and in this case we're going to use the setf function, and I'm going to use if I type in iOS 2 colons, there's a number of flags that I can set for my output, and you can look these up on the web, going to the MSDN website. But in my case, I'm going to use the show point method, and what this does is it'll show a decimal point. So cout.precision will set the number how many digits of precision will be used. Cout iOS : show point will show a point. So I'm going to hit Control F5, the shortcut for running my program. And let it build. And what we see is, while before there wasn't, what we see is up here where we did our first write, we get this type of output. Down below where we set the precision and then set show point, we always get a point. So feet, we notice up here doesn't have a point, and also we always get 5 points of precision, so that's why that 0 showed up under point. And same thing up here under number, we had 6 points of precision before, now we only show 5. So this allows us to control how many digits are displayed and also whether or not we are going to show the decimal point. I forgot I didn't make a /n here, so it didn't put a lot of space between. And also, it's interesting to note that we can use ENDL or endline to do an endline. That's the same thing as a /n as well. The next flag we're going to show is iOS fixed. And so if I type setf iOS fixed, what will happen is it will again change the display. So I'm going to hit Control F5. And this time what we see is, with fixed set, now the precisions are, it forces the precision after the decimal point. So whereas we only had 1 0 after feet, now we have 5 zeros because it's forcing 5 digits of precision after the point. Same thing with number. The next function that we're going to use will be one where we need to include another library. So we're going to, at the top of our program, include IO manip, and that's the IO manipulation class, and it provides us some functions that we haven't had available until we include it. So once we have added that include statement, it gives us access to a function called setW. And what we can do with that is basically the following. We can use the setW within our cout statement, and what that will do is it will set the width of our output that's coming up. So when it displays pi, it will force it to use 12 characters, and we're going to do that for each of these variables. And so we included at the top, we included iomanip, and then down here when we display our output, we're going to set the width. And I set the headers so that they're all the same length. That way it makes it obvious what's happening. I hit Control F5, build my project, and once it builds, we can see that whereas these outputs are all kind of ragged, here we have our headers all nicely lined up, mostly because we put the spaces in here, and then we use the set12 so that setW12 function so that all of our output is nicely lined up. You can use this in order to create nice looking tables in console applications. We can also use these flags in order to display things in scientific notation. So first I'm going to unset a flag, and we use the unset function to basically turn off a flag. The flags remain in effect until you unset them, so you have to unset them in order to, if we want to display things without that configuration set. So here again we're going to, and it looks like I got my numbering off. This is actually the forthright, and this is the fifth. And to display something new with scientific notation, we have to, what we're going to do is, again, we're going to call a function which is also part of the iomanip library that we added, and it's called setIOS flags, and we're going to set an iOS flag called scientific. So above we set F, here we're setting iOS flags, and we're setting scientific. And what that will do is it'll show this notation in scientific notation. So after hitting Control F5 and building this program, we can see that now everything is displayed in scientific notation. So this e times 10 to the 0th or 10 to the 3rd or 10 to the 2nd. This allows us to display things using scientific notation. Now that we've displayed things and formatted our output, the next thing we're going to do is look at using strings. So the first two variables I've declared without initializing them, and the third one I'm going to initialize. So name, school, and favorite language, or favlang, are now been declared. We'll display a little header and then get some user input. So a string, we here see in favlang, we declare a string by using the string type, and rather than just one character like we would get with char, we can actually have a piece of text which has multiple characters in it, and the way we delimit it is with these double quotes on either side. So to declare a string, you have to do those double quotes. If you didn't have those, you would, as you can see, get an error, because the compiler tries to resolve this as commands. So the double quotes tells the compiler that this is in fact a string. To get user input, we're going to display a message telling the user what to do. We always have to tell the user what input we want. And then we're going to use a new command called getLine. And getLine allows us, we pass getLine a source, which in this case is we use cin for the standard input, which is basically the keyboard, and then we're going to pass it a string, which is a variable that we want to use to hold the result of our getLine command. Now, as we can see, getLine is undefined. So what we have to do in order to use getLine is we have to add another include statement. And the include statement we need to add is string. So the string library gives us getLine. You can see that when I added string, the red squiggles that were underneath getLine showing there was an error went away. So now we have the getLine function. And we're going to get some more input from the user. We're going to get their school name, use another getLine. From the standard input, we're going to get school. And then we're going to display the results. So I'm going to run it. I'm hitting Control F5. And we see that we get our header, and it looks like we need some carriage returns in here to make this look right. So I'm going to put those in. It's not a bad practice putting these at the beginning of the line, that way no matter what happened before, it should work fairly well. I'm going to build again. And we see we got our other output that we had before, and there's the header, C++, programming student demographics, enter your name, your school, and we see that it took the input, it put it into the variables name and school, which we declared up here, and then it displayed the information. So that demonstrates that we can get input in, bring it in as a string, and then we can use that information. Now that we know how to get input, the next thing we're going to do is demonstrate using some string functions. There are some functions that allow us to do things with those strings. So again, I'm going to declare some variables. And output some information so we know what's going on. Once again, I'm going to get user input, and I'm going to ask them for a sentence. The getLine method will give me the user's input, and we're going to put it into sentence. We'll ask user to provide us a word. And then we'll use getLine again to get that word and put it into the string variable called word. And now we're going to use some string methods to actually do some work. So I'm going to get if I wanted to know the size of the sentence, I could declare a variable called sent size or sentence size, and I'll take sentence, which is a string variable declared up here and that the user inputted some value into, and I'm going to put the dot operator. The dot operator is an operator that gives us access to class functions and properties. So in this case, by hitting that, we see in IntelliSense it shows us what functions are available for this string called sentence, and one of them that's available is the size function, and if we hover over it or select it, IntelliSense will kind of tell us a little bit about it. And so it'll tell us what it is and where this is coming from. But what we can also look up on the MSDN website what the size function does. If we just type in string C++ MSDN and size, we could search for its documentation and it'll show up. But what it does is it basically tells us how many characters are in that string. So this will tell us the number of characters that are in a sentence. Similarly, we're going to do the same thing with word size, and we'll use the size function on that by using that dot operator and then size. And we also want to find where that word might be located inside of the sentence. And we can do that by, again, declaring an integer for word in sentence. That will hold the position of that word, and then we can take sentence, use the find method, and we'll the find function. It takes one argument called word, and what it'll do is it will take this word that we got from the user, and then it'll search through sentence and tell us the position of that word is located in there. If it can't find it, this command right here will result in a -1. And so then we can show that information to the user. We'll show the sentence that they provided us. We'll show them the word that they provided us. The sentence size that we calculated using the size function. And the word size. And then the word location in the sentence. And we'll tell the user that -1 means not in sentence. And finish up with end line or carriage return so that we have an empty space after this is displayed. So next I'll build this. I'll hit Control F5. Since it's out of date because we added code, we'll say yes to building it. Oh, we forgot a pipe command. Notice that when I get an error, I can double click on the error in the error list. It'll bring me to where that's located, And let's see what we have the error at. There we go. We had an extra character in there. We'll try building again. And it's still running all of our previous code, so we'll answer the questions from the previous demonstration, and that still works. And now we're going to enter sentence. And we'll enter a word. So we can see here it's asking for a sentence and a word. Those both showed up. That it then provided us an opportunity with getLine to provide user input. We got our user input, and now it does all these calculations using the size method and the find method, and tells us that the sentence is 33 characters long, that the word is 5 characters long. It returns 5, showing that score is actually 5 characters in, and that's where it's located, and then allows us to press any key to continue. So in order to understand our code, the next thing we'll do is run in debug mode. Up till now we've been running we've been running without debugging, using Control F5 and running from there. If we want to run in debugging mode, the first thing we want to do is set a stop point. And so the way we do that is over here we have a gray bar next to our code. Clicking on it, you see this red dot appear. That is a halt point or break point. If we now start in debugging, it'll ask us to build as usual. But you'll notice that Visual Studio suddenly changes quite a bit. We get this orange bar at the bottom indicating that we're in debug mode. Where our breakpoint is, we have this little yellow arrow which tells us that that's where execution is halted. And if we click on the locals folder down here, what we have is a list of all of the variables and objects that we've declared in our program. And we can see here pi is represented, and in this locals window we see the variables and what their current value is. Most of these values we see are kind of odd. They're rather largish looking numbers, and in point of fact, for example, pi hasn't been declared yet, and so what's in here is actually trash. It's whatever number happened to be in that memory location when this variable is declared. And if you hover over pi, you can see that that same value is there, so that's another way we can see what the current value is. If I go to debug, and there's 3 options here: step into, over, and out. Into will actually execute the next line of code, and if it's a function, it will actually take you to that function and start stepping through that function. Step over will execute the next line of code, but rather than stepping you into those functions, it'll just execute that and go to the next line in your current function that you're in. And step out will run everything all the way to the end of the current function, and then step you through whatever function had called it before. So for right now, what we want to use is this step over command, and you'll notice that there are shortcuts for each of these: F11, F10, and Shift F11. So it's usually easier to use F10. So I'm going to click on step over, and we notice that the arrow moves down one line. So this line, the line before it, has now been executed. We can see in our locals window that pi, there's now a value highlighted in red. That's what's now been assigned, and you can see, okay, pi was assigned this value according to this line of code, and in fact now pi is 3.14159, etc. So we can use the debugging function to step through all of our lines of code And it's a very useful function for understanding how your code is working, but also if it's not working predictably, use that step through function uh, in order to see how your program is executing and maybe find where the error is or the bug is. Here again, see feet was assigned 5200. We see that pi now is no longer highlighted in red because it's old news. The only things that are highlighted in red are the things that were changed since the last update. So every time we step over, it's going to do that line of code and then execute what happens next. Thank you.